Hi, in this tutorial we are going to solve a question related to naming of alcohols and phenols. The question asks, give IUPAC names for the following compounds. Let's start from the first option. In the first option, let's look at what kind of molecule is this. This contains a hydroxy functionality and an alkene functionality together. So basically, this is an alcohol having a double bond functionality, which is an alkene. The rule says that for alcohols, we have to find the longest chain, and the longest chain has to start from the end nearer to hydroxy functionality. And since this is an alkene also, the naming of alcohol will be dominant. So basically we have to follow the naming of alcohol rules, but we have to also include double bond in the longest chain. So let's start numbering the longest chain. So we have to start from this end because this end is closer to hydroxy functionality. So this is number 1, number 2, number 3, number 4, number 5, number 6, and number 7. So the longest chain, including hydroxy and double bond, contains 7 carbon, and at the second position we have alcohol, at the third position we have a methyl, at the fourth position we have ethyl, and at 4 we have an alkene functionality, and the longest chain is 7. So let's include all this in naming. So let's say that this is 7. 7 is heptane if it is an alkane functionality, but this is not heptane. It includes a hydroxy group, so this has to be heptanol. But we have to also include carbon-carbon double bond functionality, which is an alkene. So this is a heptanol. Okay, so we included both alkene and alcohol functionality in the name, basically. Then we have to specify what kind of substituents we have. We have a methyl at third, and we have an ethyl at fourth position. So alphabetically, ethyl comes before. So we have to say that this is 4-ethyl-3-methyl. Then it has to be heptanol. And then we have to specify where is the hydroxy functionality and where is the alkene functionality. And I'm going to use the newer naming system, which includes the numbers of the functional groups just before the suffix. So basically, let's not write heptanol. So hep, after hept, we have to say heptene. Where is the location of double bond? Double bond location is at 4, so we have to say that this is 4-ene. Then we have to say alcohol, all prefix. Then for all, that's the number 2, so we have to say that is 2-ol. So basically the name is 4-ethyl-3-methyl hept 4-ene 2-ol. So that's the official IUPAC name. But since we have an alkene functionality here, we have to always test or check whether this is a cis-trans alkene or E or Z alkene. Let's look at how many substituent around double bond we have. We have here an ethyl, a bigger substituent on the other side, and here another ethyl and a hydrogen here. So basically we have 3 substituents around the double bond, so we should use E or Z functionality or E or Z naming system. So let's look at, I'm going to draw here a rough skeletal structure again. 1, 2, 3, 4, 5, 6, and double bond is here. We have here ethyl, we have methyl and hydroxy here, and then I'm going to draw with red marker a hydrogen on the double bond. And definitely on the left side of the double bond, ethyl substituent, this one has high priority. I will show with H, capital H, not hydrogen this is. And on the right side of double bond, we have an ethyl group here, and we have another group which has a CH3, CHOH. So basically this part has high priority because it contains more carbon, and also it has a OH functionality and high priority here. So basically high priorities are on the opposite sides of the alkene. So one is facing upward, the other high priority facing downward. So this is going to be an E alkene. So I'm going to add here E. So E-4-ethyl 3-methyl hept 4 into all. Okay, basically the first part is this way. Let's move to second part of the question. In this one we have a cyclohexane ring. In this position we have an alcohol functionality, and here we have a halide, iodine, and this is going to be an alcohol, so cyclohexanol, and we have to say this is number 1 because OH is connected to first carbon, number 2, number 3. So basically this is 3-iodo. Let's write the name, 3-iodo cyclohexanol. We don't have to say 1 cyclohexanol because hydroxy carbon always should be numbered as 1. But if you look at here, both OH and iodine is a part of carbon which has 4 different groups. So basically these carbons are chiral, so when we are naming a molecule we have to include also the configuration, R or S configuration. So in addition to 3-iodocyclohexanol, we have to specify the configuration of first carbon and the third carbons, which are chiral atoms. Let's start from the number 3, and I'm going to draw here again the molecule, then we can assign R or S configuration. I redraw here the skeletal structure. Okay, let's start from the number 3. We have hydrogen, iodine, and 2 other functional group. If we assign priorities according to Kahn-Ingold-Prelog rules, iodine has to be number 1 because it has the highest atomic number. Hydrogen has to be number 4. This carbon has to be number 2 because it's connected to an OH. This carbon, the other carbon which has 2 hydrogens and a CH2, this has to be number 3. So number 2, number 3. And let's look at the hydrogen. Number 4 is facing backwards, so it's going inside the paper plane. So let's look at 1, 2, 3 rotation. 1, 2, 3 rotation is clockwise, so number 3 carbon has to be R. How about number 1 carbon? Is it R or S? I'm going to use another color. I'm going to use a blue color for this carbon. We have to say that number 1 is OH. Hydrogen has to be number 4. This carbon which has iodine has to be number 2, and this carbon has to be number 3. So let's look at 1, 2, 3. This is counterclockwise, and we have to say S when it is counterclockwise, but hydrogen is coming out of the paper plane, so we have to say the opposite. So we have to say, instead of S, this has to be R. So basically it was a counterclockwise rotation, but hydrogen is facing or coming out of the paper plane. We have to say R. So let's write here also number 1 should be R. So when we are naming this molecule, we have to write this way. That is the proper way of naming. We have 1R, comma 3R, close the parenthesis, and then we have to say 3 iodocyclohexanol. Sometimes some people are tempted to say, since hydroxide and iodine on the opposite faces of cyclohexane, we can say trans, but it's not correct, because the opposite also, hydroxide is coming out of paper plane, iodine going inside the paper plane, can be also trans, but they are going to be SS configuration. So we have to specify the configuration of chiral atoms for this type of molecules. Okay, let's move to next question, which is again an alcohol and which has a phenyl substituent. Let's we have to find the longest chain, and we have to start from the carbon nearer to hydroxy functionality for alcohol. So this is number 1, number 2, number 3, and 4. So we have at 3 position, we have 2 substituents, methyl and phenyl. Then the longest chain is 4. So this is going to be a butanol, 1 butanol, and at the 3 position, methyl and phenyl substituent. Let's write the name. So we have 3 methyl. We have to say methyl first. Then we have 3 phenyl, because M is coming before P in alphabet, and we have to say this is 1 butanol, 1 butanol. Okay, the name is complete now. Let's move to the last option. Last option, we have a hydroxybenzene functionality, which is the common name, which common name is a phenol. So basically this is a phenol, and let's look at the substituent. We have an OH functionality at number 1, and at 4 we have chlorine. So this is 1,4 substituted, and according to IUPAC, ortho, meta, or para naming system should be used with di-substituted benzenes. So this is going to be 1,4, which is para. So let's write here, this is para chloro. Let's write with the black marker, para chloro phenol, because hydroxybenzenes, they have to be named as phenol. Okay, so basically we finished naming of 4 molecules. In the first option we had alcohol and alkene. In the second we have a halide and hydroxide on the cyclohexane ring. We had 2 chiral atoms. We included the chirality. In the first option we had an E-alkene here, and in the third option we have a phenyl ring in the alcohol backbone, and the last one was a phenol. Thank you so much for watching.